Hi students, welcome to Garud Engineering classes. I am Professor Garud. I will take your third lecture of control system. So what we had seen in control system. So what is the system and what is the control system? There is open loop and closed loop control system. Now how we present that control system mathematically. Suppose if we consider simple circuit, how to get the control system. What is the gain of the system and what is the transfer function of the system. Okay, so transfer function is what is the difference between gain and transfer function? Gain means what? Output upon input. But what is the transfer function? Laplace transform of output to the Laplace transform of input. It is called transfer function. So we know the basic system. If we consider circuit, how to get the transfer function of that. And afterwards we had seen if particular system is presented in blocks, correct? Then that circuit is huge or the block system is huge. Then how to reduce and how to make a single transfer function of that. That is the block reduction technique. So as I told, there are total 8 rules of block reduction and this particular part is already covered. So what I am doing, just I want to revise that thing and I will in this particular lecture I will cover something different part. So that is what is a pole, what is pole 0, what is pole 0 graph, what is the system, what is the characteristic equation of the system, what is the order of the system, everything I am going to explain. So if you know the basic block of control system, somebody tells you that draw basic control system, so you know how to draw the basic control system. So you know this particular block is your forward gain, that is the gain of the system. Okay, and there is also one more block that is called reverse block, that is called back system. Okay, and there is one summing point also. Okay, so there is one summing point. So this is a summing point. So these are the basic three blocks. One is the summing point. This is the gain, that is forward gain. This is reverse gain. So then how we make the system? From this side we set something like if we set the temperature of the geyser, correct? This particular thing is called RT. This we give feedback from this side. Okay, this feedback and this thing is compared. Okay, this thing is compared like this. So this thing is compared, and here what we can say, it is plus and it is minus, and here what we get, here the result, this is manipulated signal, here we get controlled output. Okay, and that control output is again fed back to the input. Okay, now what is this? So here this is R of t, you know, but in Laplace we can say R of s. This is plus and here whatever the subtracted is minus. This is manipulated signal, we don't consider that. Here actually it is called g of s. What is s? S is the suffix for the Laplace. This is back signal which is called b of s. Okay, or it is also called h of s. So this can be written, back signal is also can be written with h of s. Okay, and here is the takeoff point. So you know this is the takeoff point. So there are 4 parameters actually we must know. This is summing point. This is takeoff. Here we are taking signal. This is back signal. Now what is this particular thing is control signal. So what is this control signal? How the control signal is presented? This is C of S. Okay. Then what is the transfer function? Transfer function is, it is always in Laplace, correct, is equal to output upon input, Laplace output upon input, that is what, C of S upon input is what, R of S. Now what is this is presented? Transfer function is always presented, transfer function equals to, you know the derivation of this, using derivation we get the system, and you know that is G of S upon 1 plus G of S into H of S, correct? So this is your transfer function. This is very important parameter, correct? So if this particular system is presented by basic system, then the transfer function is always presented by g of s upon 1 plus g of h of s. Now, thing is what? This is real system. Like, suppose if I set the temperature, okay, if I set the temperature here for 70 degree geyser temperature, I want geyser temperature as 70 degree. But the real temperature, if the real temperature is 30 degree, that is water temperature 30 degree, that 30 degree is going to compare. Here it is 30 degree as I told last time, correct? So 30 minus 70 minus 30. So 40 degrees error, correct? If there is error, this geyser will turn on. So because of that temperature will increase like 40, 50, 60, every time it is going to compare. When it reaches to 70 degrees centigrade, so here comes back to the 70 degree. So here it comes to the 70 degree. 70 minus 70, what is that? Error is 0. This particular part is error signal, E of S, always. Correct? This is manipulated as a C of S. So when error becomes 0, automatically geyser will turn off. So this is what? This is the real system we use. Then what is this? This is the mathematical presentation of real system. So what type of this system? Every time this is heating temperature? No. If I use a bike, then I can present like this. If we are launching the missile, correct? Then this missile I can present like this. If I want to control one industry, I can present using this. Yes, but and if suppose there is a circuit also, we can present this. But what is this? The final circuit is presented in mathematical expression. Now, using mathematical expression, can we give some judgment about the system? Correct? Whether the system is stable or what, it is going to run for a long time or what. Can we give the judgment? That I want to tell you. This particular part is important. So, we will consider this part for our further discussion. Okay? So, I consider this for my further discussion. So this particular part is important. Okay. So g of s, transfer function g of s equals to transfer function g of s upon 1 plus g of s into h of s. Now thing is what? This is presented, this is open loop system. Correct? This particular part is open loop part. And what is this whole part? Whole part is closed part. You know that feedback is given to the input system, that input is always comparing that system and geyser will turn off automatically. Now thing is what? This particular system can, this particular output, mathematical expression, can present or tell something about the system. So if I consider, see, if I consider this type of circuit, capacitor, and you know how to draw the transfer function of this. So basically this C, okay, this is R, okay, from this side it is V of I, this side is output VO of T, okay, like this. So what is the transfer function of this? Transfer function always presented in Laplace. So what we have to do? We have to first present into Laplace, correct? So we have to present this into Laplace. What is the Laplace of this? This is Laplace of this is R. What is the Laplace of this? 1 by Cs, okay? One by Cs, correct? So you know what is the transfer function. Then also we can calculate about this. So transfer VO is equal to I use white pen. VO equals to voltage here, that is input voltage Vi into this 1 by Cs upon this plus this potential divider. R plus 1 by CS. Correct? So we want what we want? We want VO by VI. If I take VI this side, correct, that will be 1 by CS. So equals to I write 1 by CS upon I take LCM of this. This is RCS plus 1, the whole thing upon CS. CS cancel. So it is what? 1 upon 1 plus RCS. Okay, and if we simplify this, what is that if I divide by RC here? Divide by RC, this is 1 by RC. So this particular part is already covered. Here it remains S only, that is 1 by RC. So what is the transfer function of this? So if I take 1 by RC common, correct, this is constant that depends on R and C. Correct, what is this? This is 1 upon S plus 1 by RC. 1 by RC is a time constant. Correct? 1 by RC is a time constant. This is a transfer function. So how it is presented? Is it presented in this way? Yes, it is presented in this way. So like this, if I say, if I want to present this, like if I consider any parameter, if I say S plus 2 upon S into S plus phi something. So whatever transfer function we get in the real practice, that time what we get? We get something in terms of SSS. This is what we can say. I can use this as a, this I can tell you, this is, yes, this what? It is in Laplace. This what we get? Constant. Here what we get? Constant. So the parameter I consider next part. So system is always presented, transfer function is always presented, G of S upon 1 plus G of S H of S. This is block. But this can be also written in terms of S into something S plus A. A means constant. In bracket S plus B. In bracket something like this. The divided by something here may be S or it may not be S here. Suppose if I cancel out this S, then here will be S. Okay. Suppose if we cancel this, correct? Then here write S raised to 2, S raised to 3. I can mention S raised to n into. Here I say S plus, if I consider ABCD parameter here, I can say, here I can say K. This is another constant, S plus M, S plus P, and so on. So if any transfer function you want to express, this is what we can say standard presentation of transfer function. So we will consider standard presentation of transfer function in terms of S. So I write that. Here I want to write how transfer function is presented. Transfer function is presented. Transfer function equals to something I write S plus A, S plus B, S plus C, and so on, divided by S raised to n, S plus something, another parameter I consider K. This is constant. A may be anything, 1, 2, 3, 4, 5, something like this. S plus J, S plus M, and so on. Correct? What is a real example? Real example I can write. Transfer function S plus 2, S plus 3, S plus 9, like this, upon S raised to 2, S plus 4, S plus 5, enough. So this is the real presentation of transfer function. Now thing is what? Here I want to tell you about this. This is standard presentation of transfer function. Okay. This is standard presentation of transfer function. Now, by judging this transfer function, can we tell something about the system? What is this? Here, if I say, what do you mean by n? What is n? What is here? What is A? Okay, A, B, C, D, and all. What is K? That we have to present it. N means called order of the system. Okay, if S reaches to 0, S reaches to anything raised to 0 is what? 1. Means nothing is there. That time that is always 0th order. If S raised to 1 means simple S, that will be first order system. S raised to 2 means second order system, third order system, fourth order system, fifth order system. Like that, there are different orders of the system. As we go on increasing orders of the system becomes more and more complicated. Correct? 0th order is always very simple system. Okay? And nth order is a very complicated system. Okay? Now, what is the ABC upper parameter? Now, suppose you want to make the transfer function. Here you want to make the transfer function. Suppose you make a value of s equal to 0. What will happen? Suppose here if you substitute here the upper part. So upper part, if I say here I present, here I write s plus a, s plus b and s plus c. I want to make the 0. This denominator I want to make 0. What to do? What will be the value of s and what will be the value of that a, b, c? Okay. So if I want to make numerator 0, sometime I want to make denominator 0, then what is that? If I make a numerator 0, so what is that? Here I can say 0 divided by anything. What is that? 0 divided by anything is 0. So how this particular system becomes 0? If I substitute any of this is 0, like if I substitute s equal to, here suppose s is equal to, here if I go 2. So if I substitute s equal to minus 2, then what will happen? Minus 2 plus 2. This terms become 0. 0 into anything is what? 0. So if numerator is 0, whole system becomes 0. Okay. So either this term is 0, or this term is 0, or this term is 0. Any term if I make a 0, system becomes 0. Suppose if I consider s plus a, if I make that equal to 0, then what is that s? S equal to minus a. If I substitute s equal to minus a here, then minus a plus a, what? 0. 0 and anything there. Here also if I make s plus b equals to, I want to make 0. Now what is that s? S equal to minus b. Okay. Here if I substitute, what is that? S equal to minus c. So there are 3 parameters like s equal to minus a, s equal to minus b and s equal to minus c. There are 3 constants that makes this particular system 0. That's why A, B, C, D are called zeros of the system. Okay? Why A, B, C are called zeros of the system? Because if we maintain that s equal to minus a, s equal to minus a, s equal to minus b and s equal to minus c, any of that, if I make this particular term 0, whole system becomes 0. Okay? That's why A, B, C are called zeros of the system. Okay, as I told you, what is the order of the system and what are the zeros of the system. Now, something K, J, M that I want to explain. Okay. Now see, what is K and that? See, if I make this particular part 0, here if I make S equal to 0, what will happen? What will happen? Anything, transfer function, something, anything divided by 0. What is this? This, if I make S 0, 0 into anything is 0. If I substitute S is equal to minus K, what will happen? S equal to minus K. This terms becomes 0. 0 into anything what? Becomes 0. So anything divided by 0 is what? It is always infinity. So what is the meaning of infinity? System gain transfer function becomes infinity. Infinity is very high. Extreme end. Extreme end is also called pole of the system. Correct? So if the value of S that makes system value infinity called poles of the system. Correct? So we got three things now. So three things. What is the order of the system? What is the zeros of the system? And what is the poles of the system? Simple. Okay. So I will take example of this also. But here I want to tell you, suppose this is your standard system, closed loop system. This decides the order of the system. Upper constants, value of S that makes transfer function, value of transfer function 0 is called 0 of the system. Value of S that makes value of transfer function infinity is called pole of the system. It's very simple. Now I give you one example. Now you have to find out what is the I write here, find order zeros and poles of the system. Okay, and system is transfer function equals to S plus 2 S plus 3 S square S plus 1 S plus 5. Okay, now your answer must be tell me your answer. Okay, first we have to find the order of the system. Order means S raised to n. This system can be presented in terms of standard S raised to n. So what is n equal to? N equal to 2. So what is the order of the system? Order of the system is 2. Okay. Now what are the poles of the system or zeros of the system? Tell me 0. What value if we substitute the system transfer function becomes 0? If I substitute S is equal to minus 2 here. Okay. Then minus 2 plus 2 will be 0. So S equal to minus 2. Then S equal to minus 3. These are zeros of the system. What are the poles of the system? Poles of the system. Here S equal to 0. If I substitute, so S equal to 0. There are two zeros. S into S. Now here will be S into S. That is S square. So there are two zeros. Okay. Then S equal to minus 1. And S equal to minus 5. These are what? This is the solution. This is what? This is your answer. Okay. Now I give you one more example. Now you have to find out that. Now I tell you. I give one more example. Suppose transfer function equal to S plus 5 S plus 3 and S plus 2 S plus 4. Find order of the system. Okay, what is order? What is the order of the system? What is s raised to n? Nothing. S raised to 0. So what is order? Here nothing is there. That is 1. 1 into anything. So what is order? Order is 0. Correct? What are the zeros? What are the zeros? What are the zeros? Here if I substitute s equal to 0. Yes, first 0. Here we substitute s is equal to minus 3. Here we substitute s is equal to minus 5. Okay. Then what is pole? What are the poles of the system? Very simple. Poles. Here nothing is there. Here minus 2. Then here minus 4. Now what if I write like this? What if I make like this? Here if I say here, I say minus here. Okay, then what will happen? This particular term, I say, this particular term I make equal to 0. So s minus 4 equal to 0. S equal to what? 4. So if there is a minus sign, okay, if there is a minus, then what will happen? Here it will be plus. So simple it is. Okay, so now thing is what? How to present pole 0 on the graph. Okay, but before that I want to tell you what is the characteristic equation. Okay, see. Suppose transfer function is mentioned like this. Transfer function equals to g of s 1 plus g of s into h of s. Correct? Now, this particular transfer function says something. What is that? By judging this, here they go. The g of s, this particular part is called complete part. See, already this is having forward and feedback. So this particular part is called, characteristics equation. Characteristic equations, what that 1 plus g of s, h of s, we have to find the roots of this equal to 0. This is what we can say characteristic equation. This particular part is called characteristic equation of the system. So any system, if I consider numerator and denominator, if I make denominator equal to 0, that is called characteristic equation. What is that then? This is g of s, h of s equal to what? If I take this, this is minus 1. This also we can present. Correct? So this is something related to the characteristic equation. Now can you find the characteristic equation of this, or roots of the characteristic equation? Find equation and roots of that, of characteristic equations. Transfer function equal to divided by okay. So you know characteristic equation is always presented by q of s. There is a sign, that is this what, okay. So s g of s, I can present this with the standard system. Standard system is what? G of s upon 1 plus g of s into h of s. Okay, so you know this particular thing is called characteristic equation. It is comparing, say this is something forward divided by something. So this is g of s equal to 0. This is characteristic equation. Correct? So what is that? S equal to what? 0. First, s equal to what? Minus 1. If I substitute here, Okay, then s equal to what? Minus 4. So this is s1, s2, s3. What is this characteristic equation gives you? Zeros or poles of the system. Characteristic equation gives poles of the system. So how to present the equation of the characteristic equation? This is the thing. Now suppose if I say one more thing. I mentioned g of s equal to s upon s plus 2. Then I say, this is question number 4. Find characteristics equation. Then what will be the answer? You know what is characteristic equation? Characteristic equation is equal to q of s equal to 1 plus g of s into h of s, and that we have to make equal to 0. But what is given? What is given? Only g of s is given. This is open loop system. This is not closed loop system. So we have to write the characteristic 1 plus. What is g of s? S plus 3 upon s into s plus 2. But what is h of s? This is feedback system is not given. There we have to consider h of s equal to 1. This is called unity feedback system. They will mention also unity feedback system. Okay. If unity feedback system is not mentioned, then we can write it is h of s equal to 1 also, and we have to consider that as a unity feedback system. So what is that? 1 plus g of s into h of s equal to 0. Okay, now take LCM. S into s plus 2, this thing, plus s plus 3 upon, take LCM of this, s into s plus 2 equals to 0. Okay, now if I multiply this into 0, what happens? 0. So I can write s into s plus 2 plus s plus 3 equals to 0. This can be multiplied here. That becomes 0. Okay. Now, what is this? I want to reduce this because I need space. Okay, so here I want characteristic equation. So this is s into s plus 2, s plus 2 equal to 0. Now I will solve this. What is that? S square plus 2s plus s plus 3 equal to 0. So how many? That is s square, only one s square, 2s plus 2s plus s, what is that? 3s plus, this is constant, equal to 0. Okay, this is what your characteristic equation. This is q of s equal to. So you got this. How to find the characteristic equation if only g of s is given? Simply, what we can write? 1 plus g of s equal to, like this. So I consider one more example for this. Find characteristic equation if g of s equal to s plus 3 upon s plus 4, s plus 5, and h of s equal to s plus 2. Okay, then we can write answer. So what is that? Now you know characteristic equation Q of S equal to 1 plus G of S into H of S. So we can substitute the values 1 plus, what is G of S? This is the G of S. So S plus 3 upon S into S plus 4 S plus 5. Okay? Into, what is H of S? H of S, this is given. Now here H of S is not a unity feedback system. It has got some feedback. Now we have to solve this. Equals to, I take LCM of this. First I will take 1 plus 1 plus S plus 3. This is multiplied. So S plus 2 upon S into S plus 4 S plus 5. Okay. So again we take LCM. LCM is what? This thing. So I can multiply this here. S into S plus 4 S plus 5. Okay. Plus, here is a plus. S plus 3 S plus 2 upon, we take LCM, S into S plus 4 S plus 5, and you know characteristic equation equal to 0. 1 plus G of S H of S equals to 0 always. Okay, so we will consider this for my further. I copy this. Okay, I will take it on next page. So this is the last part. Okay, now what we want, this is equal to 0. So when this particular thing becomes, if I take this side, what will happen? This becomes 0. Okay, so here I write now S plus 4 S plus 5 plus S plus 3 S plus 2 equals to 0. Okay, because this term becomes 0. Now we have to solve the bracket. First I want to solve this. S into S square, S into 5 5S, plus 4 into S 4S, plus 4 into 5 20, plus I will solve this. S into S square, S into 2, that is 2S, plus 3 into S 3S, plus 3 into 2 6 equals to 0. Now again I will multiply this S inside, that is S cube. Okay, plus this will be 5S square plus 4S square plus 20S, plus here we don't have to multiply anything, plus 2S plus 3S plus 6 equals to 0. We solve the bracket. Okay, now we have to combine. How many S cube? Only one. How many S square? S square, S square, S square. Okay, so here I write S cube plus 5S square, 4S square, 9S square plus 1S square, that is 10S square, plus how many S? 20S, 2S, 3S. So how many S? Okay, S square plus 10S, 20 plus 2, 22 plus 8, 25. So that is 25S plus how many constants? Only one, that is 6. equal to 0. Correct? So this is what? This is our final equation. What is this? So now I tell you about this. So the question was, find characteristic equation of this. G of s is given and h of s is given. So you know what to do for the characteristic equation. There is a standard equation, that is 1 plus g of s, h of s equal to 0. G of s is given, mention here g of s, h of s is given, multiply here, and that is equal to 0. Now what we do? First do multiplication s plus 3 and s plus 2, s plus 3 and s plus 2, remaining part as it is. Now I take LCM, this should be multiplied over here, so same to same remains same, s plus 3, s plus 2 becomes here, and total LCM will be this thing, that is s into this. But if when we multiply with this becomes 0. So if I multiply with this becomes 0. Okay. So only the upper part, numerator, remains. Now we have to solve the bracket. If we solve the bracket, we have to collect the terms like cube wala terms, then square wala terms, then s wala terms, that is s means s raised to 1, and simple constant, that is the 6. So this is what we can say characteristic equation. They ask for 4 marks to find the characteristic equation from this. Okay, so we will revise everything what we have studied today. So we have studied today that what is the transfer function, what is the control system, and how it is presented. You know, this is previous case. And what is the transfer function from the derivation we can get, that is covered in second and third lecture. The transfer function is always presented by equal to 1 g of s upon 1 plus g of s h of s. Now if we consider this as a transfer function, then this transfer function can be presented for any system, like suppose that is a geyser system, so we present that. Suppose if we consider circuit, then also we get this type of thing. Then if we add something into this, if we add anything, register here, if I add register here, the transfer function will be different. But by judging the final equation of transfer function, can we judge anything about system? So that we are going to see about the mathematical equation. Now if we consider that particular part, so transfer function is equal to, this is the standard part. Then how we get everything in terms of numerator, we get in terms of s, denominator we get in terms of s. So different constants we consider like this. So this is the standard format of any type of transfer function. Okay, then what we do? Now if we consider a standard format of transfer function, so transfer function is always presented s plus something, s plus something, s plus something will be multiplied. Suppose there is s here, there won't be s here. So s raised to n something, s plus constant, s plus constant, s plus constant. Okay, then what is that? The system, then we find order of the system, zeros of the system, and poles of the system. Value of constant or value of s, that becomes value of transfer function zeros, all called zeros of the system. Okay, values of s, that makes values of transfer function infinity, these are called poles of the system. Okay, poles of the system. Okay, what is order? This is what we can say order, nth order, second order of the system, that we have seen. So value of this is what we can say, how to get the values of that. Directly we can substitute here. What is 0? S is equal to -2 and something. Okay, then we had seen one example. Find order, zeros and poles of the given system. So you know n raised to 2, that means 2, this is second order system. S is equal to, if I substitute s is equal to -2, the whole thing becomes 0. S is equal to -3, whole thing becomes 0. Because 0 and anything is 0, so zeros are -2 and -3. What is the pole? Pole here, S, there are two poles, so S is equal to 0. Okay, S is equal to -1, if I substitute S is equal to -1. Okay, then here we can substitute S is equal to -5, so this whole thing becomes 0. Anything divided by 0 will be infinity. Infinity means extreme end. That is what we can say, pole of the system. Then this is another example, something like this. Then same thing, find order, zeros and ports of the system. Okay. Then this is the transfer function. Now we will be actually concentrate on characteristic equation. Why it is called characteristics equation? Because this particular system also contains g of x. So there is a numerator and denominator. This. So what we have to do? We don't have to consider this. Only studying this, we can get the judgment of this about the characteristic of that is equation of that. This particular equation says characteristics of that particular system. So this is what this is the standard equation we got, characteristic equation. Now using the characteristic equation, we can solve the problems, find characteristic equation and roots of characteristic equation. Suppose this is the thing, this should be 1 plus something. So if we write this is equal to 0. Numerator, and that we get roots of the system. Now next we consider one more example. Only g of s is given. Then characteristic equation, only g of s is given. Then 1 plus g of s into h of s equal to 0 is the characteristic equation. So if we substitute that and like this if we multiply with the 0, and then this will be the equation. Just simplify that and it is written over here. Okay. So this is question number 4. Then next we consider one more. Only now g of s and h of s both given. That time in previous case what happened? Only g of s is given. H of s is not given. So that time what we consider? We consider h of s equal to 1. That is called unity feedback system. As I mentioned here, unity feedback system. But here the system is not unity feedback. H of s is given. So we have to multiply that. So this is g of s. Whatever the g of s is given, h of s is given, just multiply that, take LCM of that, okay, take LCM of that, you multiply with this and solve the equation, we get this. So this is all for today. In next lecture I will tell you something about how to plot port 0 on a graph. Okay, bye.